So continuing on with our topic 1, motion, we're looking at acceleration. So it says, if an object is speeding up or slowing down, it is no longer moving with uniform motion. Instead, it is said to be moving with non-uniform motion. Acceleration is a type of non-uniform motion that describes the change in velocity that occurs over a specific time interval. Acceleration is typically measured in units of meters per second squared. So what you see here is the formula that we use for acceleration, and it has A meaning our acceleration, and then our velocity. It's split velocity into velocity initial and velocity final, and those basically mean what were you going at the end minus what were you starting at, and then it's all divided by our time. And our time could be, there could be multiple times, so you might also have to take your time final minus your time initial, but we will come to that when we get there. What's really important is that this is always measured in meters per second squared, okay? Your velocity is measured again in, why am I doing that? It's measured in meters per second, and then your time would be measured in seconds, okay? So here's some examples that we will try this question out on. I'm going to see if I can, I'm going to do this over in the notes, but I'm going to copy it to see if this works. Perfect. Learning new things every day. All right, so this question says, a car traveling 70 kilometers an hour east speeds up over a period of 4.5 seconds to travel at a velocity of 90 kilometers an hour east. Determine the average acceleration of the car in meters per second squared. Okay, so what we're trying to find out, it's saying in this question, is our average acceleration. Oh, I can't write up there apparently where that is. That's okay. So it's trying to figure out our average acceleration. So I'm just going to rewrite our formula that we had on the last page, just so we remember what we're trying to figure out. So all of these pieces, we've got acceleration, velocity final, velocity initial, and time. So let's see if we can figure out what pieces are there. It says a car traveling 70 kilometers an hour east speeds up over a period of 4.5 seconds to travel to a velocity of 90 kilometers east. So initially, it's saying we started at 70. So this is where we're going to put our 70 kilometers an hour. Then they were speeding up to a velocity of 90 kilometers an hour east. Make sure you put the east in there, because I forgot to. And then our time, it says 4.5 seconds is how long it took. So that would be our time. Okay, so we've got all those pieces. It's saying determine the average acceleration. That's what that A is. So we need to plug all these pieces of information in our formula, and we can solve for our A. So our first piece of information that we're going to plug in is our VF. And our VF is right here, which is 90 kilometers an hour. So we're going to write 90 kilometers per hour. That's minus, so it might be a good idea to put that in brackets. Something else before I move on is that this says east. So see how we've got east? When I'm doing these types of questions, I like to change the east, west, north, south stuff into positives and negatives. So east, if you remember, if this is our north, east, south, west, this way is positive, this way is negative, positives up, negatives down. So if we're talking about east, to go east would mean that we're in a positive direction. So I'm actually going to get rid of the east part, and I'm going to put positives here. So in my question, I'm also going to keep that positive. VI is 70 kilometers an hour. So we're going to write that into our thing as plus 70 kilometers an hour. And then we are going to divide that all by our time. And our time is 4.5 seconds. Okay, so now we can calculate that. So we can just plug this into our calculator and calculate it. So if we do our 90 minus 70 in our calculator, we should get 20. Make sure you keep that positive. So that's 20 kilometers an hour over our 4.5 seconds. So if we divide those two, 20 divided by 4.5, we get a number of 4.44 repeating. I'd like you to keep 2 decimal places, and that's in meters per second squared. Okay? Right, so that is that question. That's that example. I'm going to do the other examples in a second. So I'm just going to